Hey guys, Mr. Milton here. Today we're going to talk about arcs and arc lengths. In this video you should be able to identify and find measures of minor arcs, major arcs, and semicircles. And you should be able to find the length of a given arc. Okay? Alright, let's get into it. Circle above here has its center at point O. Okay, and so we can call this circle O. Okay, isn't it, with the center? Okay, each line segment from the center to the circle is called a radius. Each of these line segments have congruent lengths. So throughout a circle, all the radii are the same length. Okay, a line segment that goes through the center and has both endpoints on the circle is called a diameter. Okay, and this segment is twice the length of a radius. Okay, so up here, OC would be a radius from the center to the side. AC would be a diameter because it goes from one side through the center to the other side. Okay, the distance around the outside of the circle is called the circumference. Okay. And the formula for finding the distance is 2 times pi times the radius. Alright? Okay, so let's talk about arcs. An arc is a portion of the circle around the outside. Okay, an arc can be a minor arc, which means it measures less than 180 degrees. An arc can be a major arc, which means that's between 180 and 360. And an arc can measure exactly 180 degrees, which is called a semicircle. Okay, so those are the 3 classes of arcs. Alright, the measure of an arc is determined by the arc's corresponding central angle. For example, arc BC here is made by the radii OC and OB. Okay, therefore the corresponding central angle is angle COB. And the measure of arc BC, so arc BC, the measure of that will be the same as that central angle, 57 degrees. Okay. Furthermore, BC is classified as a minor arc. It's minor because it's less than 180 degrees. Okay. Minor arcs are named with 2 letters, while semicircles and major arcs are named with 3. So let's name some minor arcs and major arcs here. Okay, so let's name 4 other minor arcs. Remember, minor arcs means less than 180 degrees. So, less than 180 degrees, I could say arc ED. Okay, this arc. Okay, this arc is 95 degrees, so arc DC. I already named that one. We could name AB. I don't know what that is, but I know it's less than 180 degrees at this point because a semicircle would be 180. And then also arc AE. Okay, again, we could try to find out what these are later, but I know that they're less than 180 degrees. Actually, let's spend some time doing that. Okay, here I see a semicircle. Okay, diameter going through the center. Okay, so that means it has to be 180. So I don't have to think about the numbers too bad. So we have 95 plus 28. Okay, it's 123. We know that whole semicircle should be 180. So 180 minus 123, that would give us, this is 57. Right, vertical angles. What do I know? Okay, so since this is 57, then the rest of this semicircle, we know this semicircle would have to be 180 as well. 180 minus 57 gives us 123. Okay. Alright, so both of those under 180, so they're minor arcs. Now it says name 3 semicircles. Well, semicircles, remember, are 180 degrees, so we can find diameters. The diameters make nice semicircles. Okay, remember our rule for semicircles and major arcs is that we have to use 3 letters to name those arcs. Okay, and the reason is just so we can clearly say which arc we're talking about. So since I'm talking about this semicircle, I'm going to name it ECB. Arc ECB. Okay. Again, if I just called it arc EC and I was talking about a major arc or a semicircle, then you wouldn't know if I was saying go from E to C or go from E to A to C. Okay, and so that's why using 3 letters will make sure that you know, okay, you're talking about bigger than 180. Okay, another semicircle we have here as CBA, arc CBA. Okay, so we talked about this one, we talked about this one, and now we'll talk about the bottom one, which we can call BAE. Okay, so those 3 semicircles. Alright. Finally, it says name 3 major arcs. Remember, major arcs are just arcs that are greater than 180 degrees. Okay, between 180 less than 160. So I'm going to name this arc CBE. Okay, remember you want to start with the start, end with the end, but then one of the letters in between you need to use. So I'll say CBE. Okay, another major arc would be BAC or BDC. One of those you could work. Okay, another major arc, ADB. Arc ADB. Okay, so that's just how we name them. Okay, major thing, big point, big picture. Minor arcs use 2 letters. Major arcs and semicircles use 3. Okay, flipping to the back. It says use circle Q to find the answer to the following questions. Again, notice this is called circle Q because we have Q as our center. Okay, so find the value of x. Here's how we'll use it. Notice here we have LP. LP is a diameter, goes through Q, the center, and so we know that LMP, arc LMP is 180 degrees. So I can say 2x plus 3 plus 3x plus 5 plus 4x plus 1 equals 180 degrees. Adding all those together, that gives us 9x plus 9 equals 180. So 9x will equal 171. So x will equal, I'm thinking it's going to be 19, but let's see. 171 divided by 9, 19. Okay. Alright. So now we find the value of x is 19. The next question asks us to find NP, arc NP. So since it's only 2 letters, I know it's talking about a minor arc, so just this one. We already know that x is 19, so to find out what NP is, we'll plug 19 in for x. That'll give us 76 plus 1, which is 77. Just making sure that works. Yep. Okay. 77. Okay. Next, they want me to find arc LK. Alright, now this is where a little bit of reasoning comes into play because notice here, arc LK doesn't have anything here. We need to figure out what that is. The way that we'll do that, again, I recognize the semicircle, so I know the semicircle should equal 180. Okay, since x is 19, this will be 38, this will be 41. This will be 57 plus 5, 62. Okay, and so I know 41 plus 62 equals 103. 180 minus 103 gives us 77. So this will be 77 degrees. Okay, and remember that arc corresponds with that central angle. Cool. Alright. Find the measure of PK. Again, I know that PK has to be less than 180, minor arc. Okay. I already found that NP was 77, right? Nope, sorry guys, twisting the paper a lot, trying to cover stuff up. So we already found that arc NP was 77 degrees. this whole thing is 180. 180 minus 77, that will give us 103 degrees. So PK is 103 degrees. And now finally it says find the arc, or the measure of arc LMK. LMK. So that's this whole thing. Okay, L to M to K in that same direction. Okay, so I'll look at and notice that the only part that's not included in this whole circle is this arc LK. And so what I can do is I can say, well, the entire circle has 360. I'll subtract 77 from that, and that's 283. All right? So that's finding the arc, the measure of the arcs. Now we'll use that in order to find arc length. Okay? So the measure of an arc and an arc's lengths are two different things. The arc length depends on the length of the radius, while the measure does not. Okay, notice in none of this did we talk about how long the radius was or how big the circle was. Okay? The arc length is a fraction of the circumference. Circumference. Sorry. I might have still spelled that wrong. Hopefully not. Circumference or circumference? Circumference, Alright, let me just abbreviate it. Yeah, you guys are... I'm a math teacher. Alright, so here's how we find the arc length. What we'll do is we'll take the measure of the arc over 360 times 2 times pi times r. Okay, and what it is this whole circumference, and what we're multiplying it by is the fraction of the circle that our arc encompasses. Okay, the measure of the arc over 360, which gives us our portion of the circle, times the whole circumference. Okay, so let's use Circle C to answer the following questions. Okay, they want us to find the measure of arc AB. So since our central angle is 45, arc AB's measure is 45 degrees. Now they want us to find the length of arc AB, and they want us to leave our answer in terms of pi. And all that means in terms of pi means is don't multiply out pi. So don't put in 3.14, don't press the pi button, just leave it there, okay? All right, so we'll follow this formula. We need to know how big this circle is, okay? We can find the circumference of the circle by doing 2 times pi times r. And in this case, our radius is 12. So our circumference will be 2 times 12 times pi, or 24 pi. That's the whole circumference. Now, if we're trying to find the arc, the length of arc AB, what we're saying is, how much of this circle does arc AB take up? Well, the portion of the circle it takes up is 45 over 360. 45 divided by 360, 0.125, that should be 1/8. Maybe I'm wrong. I'll do the math. Fraction, where's the fraction button? Fraction and decimal. Okay, 1/8, 1 over 8. So this takes up 1/8 of the circle. 1/8 of 24 pi. 24 times 1/8 give us 3. 3 pi is the arc length. Okay, if this radius were reduced to 6 centimeters, okay, the measure of arc AB would stay the same, okay, because the measure is the angle. Reducing the length doesn't change it, it's 45. The length, though, of arc AB would change because now we do 2 times 6 times pi, or 12 pi, for our circumference, and we'd say 1/8 of 12 pi, which would give us 12 over 8, which gives us a little bit more math, simplifies to 3/2 pi. Okay? All right. Final question says find the length of arc BCA. Okay, again, 3 letters. We know it's going to be bigger than 180. So BCA, they told us that this piece was 80. So BCA then will be 360 minus 80, which is 280. Okay, and we'll use that for our formula. The measure of our arc is 280 over 360. That gives us the fraction of the circle that we're using. And then 2 times pi times r, our radius being 5. Okay, so 280 over 360, I'm going to try to simplify that in my calculator. 280 divided by 360. Change that into a fraction, 7/9. So this is 7/9 of the circle times 10 pi. Multiply that, that gives me 70 pi over 9. 70 over 9. It's not a pretty number either. 7 7/9, or 63/79. I guess that's as good as we can do it. So 70 pi over 9. That is the length of that arc. Okay, so some new terms there as far as looking at arcs and the measure of arcs and the length of arcs, but pretty simple concept. Find the fraction of the circle that the arc is taking up, and then multiply that by the circumference of the entire circle. All right, see ya.